Hello, I'm Greg Hankins with Bacharach, and thank you for joining today. Today we'll discuss how we achieve best-in-class leak rate performance and reach those under 10% leak levels. So first, we're going to take a look at data insights and give us a good understanding of supermarket leaks and why that should be part of your toolbox. Secondly, we'll look at the differences in safety monitoring versus low-level leak detection. And then finally, we'll touch on the Parasense platform coupled with the Bacharach refrigerant gas monitor that gives us that best-in-class solution for leak rate reduction. So let's take a look at data insights and understanding supermarket leaks. So a lot of businesses out there still have the old standalone system unconnected to any outside monitoring. They have a local display, limited alarm history. Most of the times, if the devices are working, the alarms are ignored and no one's alerted. And then we look at a step up from that, which is the standalone system with site alarming, usually connected to a energy management system or a BMS system on site. This gives you limited information, limited notifications, and no real time-based tracking intelligence. But then we look to the third scenario, the cloud data analytics solution. This is based on an enterprise scale that Parasense uses and gives us that graphical representation of our sites with unlimited event history. It also gives us the ability to remotely diagnose the monitor from the platform itself. And then also it gives us the ability to send out multi-person email alerts to an unlimited amount of recipients. So when we look at this chart, this is kind of a comparison to the three approaches that we mentioned in the previous slide. This data has been taken from years and years of Parasense data management. The top line indicates that 25 to 30% leak rate range. These are standalone systems, again, with no outside alarm monitoring, multiple refrigeration designs with multiple contractor resources, and usually no refrigerant management strategy whatsoever. The second orange line is the standalone automated leak detection tied into the facility BMS systems. Again, limited information and limited tracking information. But where we want to be is this green line below, and that's that 7 to 10% green shell area. These are the areas that usually have standardized refrigeration design, standardized refrigeration contractors taking care of the sites. They have an integrated refrigerant automated leak detection system with the refrigerant management software in line with that. This is also where the equipment manufacturers are aligned with the end users and businesses, and also the maintainers, to make sure that everybody is on the same page with leak rate reduction. So where do leaks occur? They occur just about anywhere in the system, and they're usually associated with a change in temperature, pressure, and vibration. They're heavily weighted in compressor rooms, evaporators, display cases. Leaks can occur in pipework, condensers, underground, overhead, receivers, TXVs, you name it. But in addition to the leakage being aggravated by a change in temperature, pressure, and vibration, we also look at the size and frequency of the leak and the regulated events such as defrost cycles, time of day, and walk-in doors being closed overnight. So what does that mean? That means that leaks come and go, and it makes them very difficult and time-consuming to find. So this is why we look to data insights to create a very resourceful tool in helping us to identify those hard-to-find leaks. So let's talk a little bit about leak levels, safety detection versus the low-level leak detection. In this slide, we're going to look at, well, first of all, I want to say that there's really an industry misconception of leak detection. And what I see that there's a lot of safety devices installed in the industry now, and I think a lot of folks look to that as leak detection. But safety detection and compliance does not equal leak detection. As you look to the chart here on the right, the safety alarm activation range is usually that range from 100 to 600 parts per million. This is not the low-level leak detection range. And these ranges, the safety range is regulated by the regulatory authorities, and you'll usually see the diffusion style sensors installed covering these these ranges. They usually require one per motor room, one per walk-in box, and they alarm at these higher levels. So you're never going to find the low-level leaks by monitoring for safety. But we do look to the early detection range here on the left of the graph with the green circle around it. These are the ranges from 1 to 100 parts per million. So these are the ranges that the aspirated multi-zone monitor will pick up. So we want to find those leaks early and prevent them from getting to this safety and catastrophic range to the right. So this slide's important as well to notice that the safety range makes up only 1% of the leaks recorded. So the safety range is the critical range from 600 parts per million and up. So what does that mean? That means that the rest of the 99% of the leaks are going undetected. So the range from 1 to 80 to 100 parts per million, we're missing all those leaks before they become those critical level leaks. So understanding leak detector placement is a very important aspect of low-level leak detection and lowering your leak rates. Knowing to use the multiple sample points, putting those sample points as close to the leak sources as possible, and then detecting those leaks down to the 1 part per million level. In this picture to the left here, it shows a leak that went undetected because there were not multiple sensors installed. The exhaust in the motor room pulled the refrigerant out. So if we had a point sensor or diffusion style sensor in place, chances are that leak would have gone undetected. So by installing the sensors at the compressors and near the leak sources, we would have picked those leaks up a lot sooner and been able to get somebody out to fix those up. So next we'll move on to the solutions by using the Parasense platform and gas leak monitors. So let's look at some of the benefits that we see from a good refrigerant management strategy. First would be refrigerant savings and reducing those operating costs. We know that on average, a supermarket will save anywhere from $10,000 to $12,000 per store per year by incorporating a good refrigerant management strategy. You also mitigate supply risk. We all know that refrigerant costs aren't going down, and they are getting harder to come by. So we also look at the environmental impact. I know a lot of companies out there now have good sustainability commitments and plans in place, and reducing the CO2 equivalent emissions per store is key to those companies. So also the regulatory fines that come with leaks, we want to try to, if at all possible, avoid those. We've all seen those in the past, and we don't want to go near that. We also adhere to the safety compliance aspect with ASHRAE 15 and corporate safety policies, and then keeping our equipment up and running and maintaining that food freshness, and making it available for folks to buy groceries. So last but not least would be the energy savings, maintaining that full charge of refrigerant in your receivers and racks and your refrigeration systems to add to that additional energy savings. So by the under 10% leak rates, they are achievable, and the way they're achievable is using that low-level leak detection down to 1 ppm, using that Bacharach aspirated multi-zone monitor, and coupling that with the Parasense data-driven software. With that, we're able to drive the refrigeration maintainers to go on site, leak check at the appropriate times, and pinpoint those leaks and get those leaks fixed. So a little more on the aspirated system. The multi-zone could be installed in a wide environment, temperature environment. It is, again, a multi-point detection device, 4 to 16 zones with expanded coverage to 48 zones per 16 zone monitor. We use a 0 to 10,000 ppm detection range, and the NDIR sensor has a 7 to 10 year life. Continually calibrates itself and does have an over-range recovery with no replacement needed. So once we do identify those leaks using the aspirated system and the data-driven insights, we look to go on site with the PGM IR portable refrigerant leak detector. This device uses the same technology as the multi-zone, measuring down to 1 ppm. The same refrigerant library of 60 plus gases, requires no zeroing, and is immune to the temperature and humidity and overexposure. It gives you those real-time accurate readings with 200 data logging points available too. So the ParaSense platform is a very resourceful tool to help in identifying those leaks early before they become catastrophic or major leaks, getting the contractors out to get them repaired. There's a lot of information that's gained upon looking at all the information that the data retrieves. The compliance software also is a very good for maintaining compliance through your estate. Looking at a site, regional, and enterprise level, it keeps you compliant with the regulatory agencies and has the reporting available for in-house use and also for the agencies as well. So to defer those costly investments in building those new refrigeration systems, we want to first look at what we have, maintain what we have, do the best job in by installing those aspirated multi-zone monitors, coupling that with the ParaSense platform to look at those data-driven insights, and then getting those contractors out to the site in order to leak check and make sure that we get those leaks repaired early and saving us tons of money and driving those emissions and leak rates down. So I want to thank you for your time today, and remember that Bacharach is focused on safeguarding people, places, and the planet. Thank you, and have a great day.